Okay, this video is going to cover how to create volume tables for section views in Civil 3D. So this is just the typical section views we have for our bridge. In this instance, this is our bridge. This is our project, kind of a curvy roadway into a bridge here. Now, I just want to show in this instance, um, depending on how you do it, there's just different ways to go about it. I have a pretty detailed corridor here that we're going to take a look at. So we've got the roadway, and I've modeled the abutment slopes coming off of the front of the bridge, all the ditching, things like that. So this is a complete model of all the earthwork and all the fills. Sometimes you don't necessarily have to do all of this, but just note it will make a difference in how we want to do our volume calculations. But especially on a bridge, it's good to go ahead and get all these abutment slopes, things like that, taken care of. So going back to our sections here, basically what we're going to do is we're going to make a table that'll pop up in the corner here for each section and show cut and fill throughout the whole project from beginning to end station, and it'll be cumulative as it goes. Number one thing, obviously you need to have a existing ground surface created. Here, that's what this is, combined EG DEM, and then you need to have a datum surface. So normally when you're creating your corridor, and if you can look at previous video for this, but you will have a top surface and a datum surface, generally reflecting. The top would be the top of the surfacing, top of asphalt, your finished grade center line, whereas your datum is going to be basically the impact of the earthwork. So that's going to be the top of the line, top of your profile before you start putting your surfacing on there. So that's true earthwork quantities. And so as long as you have these two, you should be able to compute this. So what we're going to do here is we're going to go up to the Analyze tab and over to Compute Materials. So this is our volumes dashboard. So there's another video where you can create volume surfaces and just get the values for the total project, kind of for the whole thing, but you're not going to get the table broken down by section. Hopefully they should come out the same way, but this one will just basically give it to you per section. So we're going to compute materials. We want to select the alignment. In this one we just have our center line alignment. And you select sample line group, we just have the one. Okay, and so now we're going to take a look at the different criteria. So quantity takeoff criteria, we want this to be earthwork or earthworks. And there's a couple different ways to calculate volume that we're going to talk about. So the average end area, this is kind of the old school, the common way to do it. And if you just say had your section views and nothing else, your average end area would basically compute the cut and fill in each section. Go in here and you could actually manually do this yourself. Figure out the area for the cut and fill in this section, do it for this section, and then basically you figure out the distance and divide that by 2 to get an average between those two, and that's what that is. Well, that's what this does, and it calculates it. Obviously in areas, think about when I just showed you that bridge, when you have abutment slopes, so maybe one of your sections is right in the middle of the bridge, and there's no fill, there's no cut, anything there. It's just nothing. Well, if you're taking an average from either side, it can cause your earthwork to be off a bit. That can be fine if you have, say, an extra percentage to add to it, or just different things. But if you do this other method, which is the composite volume, it's essentially doing the same thing as your volume surface, And again, this assumes that you have a pretty good corridor, which is complete earthwork. But it'll calculate it just total volume. And it doesn't bother with the area of the actual printed sections. It just takes total volume and figures it out for between the sections. Okay, this is more accurate, assuming you have a fairly accurate corridor. So that's kind of the rub there. So here we want to click which one exists in ground. That's going to be our combined EG and our datum surface. So we're just selecting surfaces. You would do the same thing. Average end area, it looks basically the same as far as clicking surfaces. Okay, and then we're just going to hit OK. And good. We did it and nothing happened. So I'm trying to think where it is. I think under alignments, centerline alignments, and click our alignment, and we click on sample line groups. If you come down here, kind of open up that, this is the hierarchy. Now there's a material list, and this is this earthwork that we just created. Okay, so that's kind of where, even though it disappeared, that's where it's hidden. You don't really need to know that too much, but that's where it is. Okay, so we have calculated the earthwork, but we still need this table. We're still trying to focus on that. So what we need to do is just click on one of our sections, and then we want to go up to View Group Properties. Let's select the graph. Okay, so since we're in View Group Properties, it will, whatever we do, will do for the whole group. So we want to come to Sections first, and we just want to turn off the draw on this. So when you do the composite volume method, it doesn't really draw anything. If you did the average end area, it would actually, the style is to draw and fill in your cut and fill sections. So we want to turn that off either way, because we don't want that showing up. Or ideally, we don't want that showing up on our sections, unless that's something you're specifically looking for. Okay, so now we go back to the Section Views tab, and we want to change volume tables. Okay, and click that little dot dot dot. So up here we want to change the type, not to material, but total volume, and select table styles. Now there's going to be some basic or different types of table styles. These are ones you can edit, change to however you want. We've got one set up that we've already done. That's what we're going to add. But again, you can select any of them and edit it as needed over here. Okay, we're going to add that. And so now we have a volume table. And then if we look down here, we can position this table relative to our section views. So the easiest way, well, it just depends. You can measure this out and you can change it however you want. We're going to set both of these section view anchor and table anchor to bottom right. And then we're going to provide an offset here. So we're going to do negative 0.05 in the X direction and a Y offset of 0.3. Okay, we're going to hit apply, and we're just going to see kind of where this pops up, if this looks good. Okay, so we've got them here, Don't worry, this one, until we hit OK, this one won't show up. But we're going to hit OK. Those look pretty good to me. Hit OK, OK. All right. So now you can see we've got our table in here, and it's just set up just right. We've got them all stacked in here nice. So one thing to note when you do, so basically that's it, but one thing to note when you do it, and this will depend, and you can change your style however you want. There's always going to be nothing on the first section, because nothing, and especially for volume, because the volume comes when you have a 3D shape. Right now we're just looking 2D, and this is the very first section. So the volume will start coming in the second one. Typically you would have a cut area. If you did the average end area method, even on the first one you potentially have a little bit of cut area to get down to your datum, or fill area, things like that. Because we didn't do the average end area method, we're not going to have any cut or fill area on any of these, because that's not the method we used. Okay, so just keep that in mind. Now potentially you could probably go back and calculate that using the average end area method and maybe add that to this table, but there's not really any point to doing so unless somebody really specifically wants that information. But now we're looking at a dynamic cut volume, fill volume, and then cumulative for each, so as it's increasing, and then the net volume, and this will carry all the way through to the end of the project. And ideally you should be able to go to your volumes dashboard, create a volume surface, and these last ones will all come out exactly the same. Okay, and again, if you want to take these cut fill area labels out of here, you can easily do that by editing your table styles and things like that. Otherwise, that's pretty much it, and that will give you your earthwork quantity tables on your section views. Thanks.